In this video, I want to talk about voltage divider circuits. But before I do that, let's talk a little bit about units. Now, we know from Ohm's law that current is equal to voltage divided by resistance. And normally, the voltage will be in volts. So 1 volt divided by 1 ohm gives us 1 amp of current flow. Now, 1 amp is actually quite a large current in most of electronics. So in this video, I wanted to use k ohms instead of ohms. So that will give us current in terms of 1 volt divided by 1,000 ohms, 1 k ohm, equals 1 milliamp. Now, a milliamp is a thousandth of an amp, but it is a unit that's much more useful in electronics. So let's now talk about voltage dividers. Let's presume I have a battery. And this battery is a 4-volt battery. And I want to divide this voltage into smaller units. And I can do that by adding 2 series resistors. Let's call this R1 and R2. Let's presume that R1 is 2 k ohms, or 2,000 ohms, and R2 is also 2,000 ohms. Let's ask ourselves, what is the voltage between the 2 resistors at this point? Now, we know from previous videos that resistors in series add. So the total resistance, the equivalent resistance of R1 and R2, is the sum of this 2K resistor and this other 2K resistor. So the equivalent resistance is 4,000 ohms. So we can calculate the current in this circuit. Current is equal to voltage divided by resistance. So we have 4 volts divided by the equivalent resistor, which is 4K ohms, equals 1 milliamp of current flow. Now, each resistor R1 and R2 have 1 milliamp of current. So we can calculate the voltage across R1 and R2. For example, the voltage across V1, voltage across R1, is equal to 1 milliamp times 2 k ohms, or 2 volts. So we've divided this 4 volts into 2 volts across this resistor, and since the same current flows through the other resistor and it's of equal value, I have 2 volts here. 2 volts, 2 volts. So if the resistors in the circuit are equal, the voltage divides equally among the 2 resistors. Okay. So I can say that this point in the circuit is, let's call that 0 volts. Now this point, midway between these resistors, is 2 volts. And the voltage at the top of R1 is the battery voltage, or 4 volts. Now there's a law in electronics called the Kirchhoff's voltage law. And in a previous video we talked about Kirchhoff's current law. But what Kirchhoff's voltage law says that if we add up the voltages going around the circuit loop, that the net voltage around the loop is 0. For example, if we start at this terminal with 0 volts and we go up R2, we come to 2 volts. And there's another drop across R1 that's equal to 2 volts. So if we go up to the top, we have 4 volts. and then we come to the left, back down through the battery, and we come down 4 volts. So at the bottom of the circuit here, we end up with 0 volts going around the loop. Now let's do a voltage divider circuit where the resistors are not equal. Let's presume I have a battery across, again, 2 resistors. Let's make the battery voltage again 4 volts. Let's make this resistor 3,000 ohms, and let's keep the math simple and make this resistor 1,000 ohms. Let's ask ourselves, what is the voltage between the resistors? So we can add up the resistors in this circuit, since they're series, and get the equivalent resistor, which is 4K. And 4 volts divided by 4K is 1 milliamp of current. 1 milliamp flowing through the resistors. So now I can calculate the voltage across the 1K resistor. It's simply 1 milliamp times 1K, or 1 volt. The voltage drop across the 3K resistor is again 1 milliamp times 3K, which is equal to 3 volts. So if I have resistors in this divider circuit that are not equal, then the voltage does not divide equally. The bigger resistor drops the bigger voltage, and the smaller resistor drops the smaller voltage. If I want to calculate the power in these 2 resistors, I know that power is equal to current times voltage. In the case of the 3K resistor, I have 1 milliamp times 3 volts, which is equal to 3 milliwatts. Now a milliwatt is a thousandth of a watt. If I want to calculate the power dropped across a 1K resistor, that is equal to 1 milliamp times 1 volt equals 1 milliwatt. Let's consider another voltage divider circuit where again we have 4 volts, but we have 4 resistors, 4 equal resistors, each 1K. So we can say that the voltage at this point is 0 volts. We know that, again, that resistors in series add together. So the total equivalent resistor of these 4 resistors is 4K. And 4 volts divided by 4K is 1 milliamp. So we have 1 milliamp of current flowing through each resistor. So each resistor drops 1 volt. So if we look at the voltage at this point, we have 1 volt. If we look at the voltage at this point, we've gone up a volt. We have 2 volts. And if we look at here, we have 3 volts. So we can do some interesting things with this voltage. For example, we could create a circuit. Now let's draw a box here that represents the circuit we're going to create. And we're going to have 2 inputs to this circuit. We'll call one input A and the other input B. This is input, input. And I want to have one output from this box that will be either 0 volts, 1 volt, 2 volt, or 3 volts. And this circuit is called a digital to analog converter. What it does is it takes digital inputs A and B and it converts it to an analog voltage at the output. Now, if I have 2 inputs and they're digital, so what that means is that the input can either be 0 volts or in this case 4 volts. So if I have both inputs at 0 volts, in that case I want to route the 0 volts to my analog output. If I have a high voltage at B, we'll say 4 volts, and a low voltage at A, I want to route the 1 volt to my analog output. Another situation, I could have 4 volts and 0 volts input. In that case, I want to route this input to the output. And the final condition I can have is 4 volts on both inputs. In that case, I want to route 3 volts to the analog output. So in a future video, we'll determine how to design the circuit. But in this video, I just want to show you the concept that you can take 2 inputs that have 4 different conditions, and you can tap off 4 different voltages and send each one to an analog output. And that's called, again, a digital to analog converter.